This video is going to be a broad overview of trigonometry, what we covered in Unit 7. It will start with evaluating trig expressions, which was covered the first 4 or 5 lessons in this unit. And then we're going to go through a brief problems that kind of overview what we covered in the subsequent lessons from Unit 7. So here are the 5 main topics of Unit 7, and this video will focus primarily on topics 1 through 4. The 5th topic, applying the Pythagorean identity, is what was covered last video, and that will be available. The question for that and the answer will be available on the OneNote. So we're going to start with evaluating trig expressions. Let's remember that to evaluate a trig expression at a given angle, it all has to do with the unit circle. Okay, so we want to find sine, cosine, and tangent for each of these given angle measurements, which are radian measurements. So we're going to start with identifying the location of each of these angles on the unit circle. Starting with 3 pi over 2, let's imagine we have a coordinate plane here. And let's recognize that 3 pi over 2, well, if we go around the unit circle in radians, 3 pi over 2 is going to be down here between the 3rd and the 4th quadrant at 270 degrees. This location will have a coordinate point of 0, -1, because remember that the radius of the unit circle is 1. So we're about 1 unit, well, we are 1 unit down from the origin here. Because it has a coordinate point of 0, -1, that will give us the x and y values. So the x value in this case is 0, and the y value is 1, or -1. And so this is 3 pi over 2 radians. So that will tell us the values of sine and cosine and tangent. So let's start with sine. Sine corresponds to the y value, which is -1 in this case. So sine of 3 pi over 2 is -1 because the y value at 3 pi over 2 on the unit circle is equal to -1. Cosine of 3 pi over 2 is going to be equal to the x value at this coordinate point on the unit circle. The x value at this coordinate point is equal to 0, and so cosine of 3 pi over 2 is 0. And then lastly, tangent is the ratio of sine over cosine, or another way to write it is y over x. And so we're going to take our values of sine and cosine and plug them into this equation here. So y is equal to -1, and then x is equal to 0. So -1 over 0, this is undefined. And so the tangent value is actually undefined here. It doesn't have a value. Okay, so this one's a little bit easier because we actually don't need those special right triangles to evaluate these trig functions at this angle. Let's do one that requires the use of those special right triangles, and that will be 5 pi over 4. So here's our coordinate plane again, and we're going to locate 5 pi over 4 on the unit circle. Well, 5 pi over 4 is going to be down here. And this reference angle is going to be pi over 4. So this whole angle here is 5 pi over 4. And we're going pi over 4 more than pi. So we're down here in the 3rd quadrant. And let's make our reference triangle. And from this, we can identify what the value of the coordinate point is going to be based on the angle measurements of our special right triangle. So if this reference angle is pi over 4, that's the same thing as 45 degrees. We know that 45 degrees is going to give us the side opposite of root 2 over 2. Because we're in this third quadrant, the coordinate point in this case is negative root 2 over 2, comma negative root 2 over 2. That's going to be our x and y values. Sine is equal to the y value of our coordinate point, which is negative root 2 over 2. Cosine is equal to the x value of our coordinate point, which is also negative root 2 over 2. Because sine and cosine are the same value here, the tangent, which is the ratio of sine and cosine, is going to be equal to, well, it's going to be negative root 2 over 2 over negative root 2 over 2. Let's remember, if we divide anything by itself, it equals 1. And so those are the three values, three trig values at 5 pi over 4. All right, let's do one more. So 11 pi over 3. I'll do that down here. So 11 pi over 3 is going to be a little bit more challenging because we are past one rotation around the unit circle. One rotation around the unit circle is 6 pi over 3, 2 pi. Two rotations around the unit circle is 12 pi over 3, or 4 pi. And so we're essentially, one way to think about this is we are pi over 3, an angle of pi over 3 less than 2 rotations around the unit circle. So we start here, we go 1 unit around, or 1 lap around, that's 6 pi over 3, and then we go 5 pi over 3 more around. Okay, so 6 pi over 3 plus 5 pi over 3 is 11 pi over 3. And so this right here is where we end up with a degree value of 11 pi over 3. So we're down here in the fourth quadrant. I think that's going to be the trickiest part about this question, is identifying just where we're located in the coordinate plane. Now that we know where we're located, we can identify what the coordinate point is by using this angle measurement. So the side opposite of pi over 3, or 60 degrees, is the square root of 3 over 2, which means this value is 1/2. And so the x value of our coordinate point is 1/2. It's positive because we're to the right of the origin. The y value is going to be negative root 3 over 2 because we are below the x-axis. Now that we have our x value and our y value, we can identify sine and cosine of this angle. So sine of 11 pi over 3 is going to be the y value of our coordinate point. So sine of 11 pi over 3 is negative root 3 over 2. And then cosine of 11 pi over 3 is going to be the x value, so 1/2. Okay, then to wrap up this problem set, let's find tangent by taking the ratio of sine, or the y value, over cosine, so negative root 3 over 2 over positive 1/2. This becomes negative root 3 over 2 times 2 over 1. And so if we just multiply across, the 2's can cancel, and we're left with negative root 3. And that's the value of tangent at 11 pi over 3 radians. Okay, so let's move on to our next topic, which is transformations of sine. And so what we're going to do here is we're going to recognize what each of these numbers here does to our sine function, and then from that we're going to make an approximate graph of this. Okay, so we know sine has that kind of wave-like feature. Let's use these numbers to identify those key characteristics, to identify what the graph of this function is going to look like. So our ultimate goal here is to graph this function here. So f of theta, that's our variable. You can think of theta as just like an x value here. So if you want to replace theta with x just to make it easier, you can, but just recognize that it's a variable. Okay, so there's going to be a few different things we're going to do here. And the key here is to identify the key characteristics before we try to graph this function. Let's start with the midline. That's usually the easiest. Okay, the midline is going to be equal to the k value, which is the number on the outside. We called it k in class. And so the midline, which is a horizontal line, is going to be written as y equals -1. And that's because this value over here is -1. So the midline is just whatever the number is on the outside. Next, the amplitude. Well, the amplitude is the absolute value of this number here. Okay, the absolute value of 2 is just 2, and so the amplitude, and in this case the a value, is equal to 2 in this problem. Now let's find the period. This is usually going to be the hardest. The period can be found from this number here. The period, let's call it p, is equal to 2 pi over b, and b is the number inside the trig function next to our variable here, being multiplied by our variable. So in this case, the b value is going to be 3 because the number on the inside is 3. So the period is equal to 2 pi over 3. So 2 pi over 3 is going to be our period. It's not that great of a period. It's going to make this a little bit difficult to graph, but let's try it. Before we graph 2, let's recognize there's actually no horizontal shift here. There's nothing that's being added or subtracted to the variable in the inside. So lastly, the h value, I'll make it orange. The h value here is 0. Okay, now let's try and graph this. So all of these will have similar shapes, but they're going to be different. So here's our y-axis. Here's our x-axis. Well, let's call it theta instead of x, and we can call this f of x. It's the same thing. The notation's just written differently. All right. So the first thing we're going to do here is let's identify the location of the midline, and then we're going to draw a horizontal line at the midline. Okay, so the midline is -1, and so let's draw a horizontal line here at -1. So this is y equals -1. All right, next, we're going to use the amplitude to find the upper bound and the lower bound of our function. The amplitude is the distance between the maximum or the minimum and the midline. So what that means is if the amplitude is 2, the maximum value is going to be the midline plus 2. So here's our midline over here at -1, and now we're going to add 2 to this value. So the upper bound of our function is equal to -1 plus 2, which is +1. And then the lower bound is going to be -1 minus 2. And so that's going to be down here. This is y equals -3. And let me make this graph a little bit longer. Okay. So now we have the kind of the center of our graph and then the upper bound and the lower bound. The period will tell us the distance of one cycle. Okay, so we're going to do two things here. Let's start by identifying the function that we're dealing with. That's going to be sine. It's a positive sine function. If you guys remember from class, a positive sine function indicates that we are going to be starting here at the intersection of the x-axis and the intersection of the midline and the y-axis. So a sine function with no horizontal shifts will start, we could start our graphs at the intersection of the y-axis and the midline, okay? So if we start here at 0, the function will repeat one cycle in 2 pi radians. So over here, let's write 2 pi. Call this 2 pi. Sorry, 2 pi over 3. Not 2 pi. 2 pi over 3 radians. So it's going to repeat one cycle from the starting point to 2 pi over 3. And let's do one more. So 2 pi over 3 times 2 is going to be 4 pi over 3. And then we can also do it the other way. So instead of 2 pi over 3, we'll do negative 2 pi over 3. So negative 2 pi over 3. And then negative 4 pi over 3. Okay, there's no horizontal shift, which is going to be nice for this question. It's going to make it a little bit easier. And so we're going to start right here. This is the trickier part because now we actually have to draw it. We're going to start here, start at 0, and then we're going to have this function go up and repeat one cycle. That means hit the maximum and the minimum and come back to where it started from 0 to 2 pi over 3. Okay? So from 0 to 2 pi over 3, it completed one entire cycle. Hit a maximum, a minimum, and return back to its original location. Once it hits 2 pi over 3, it's going to repeat the same pattern. Go up, down, and then return to its original position. Original y value. Now going to the left, it's going to repeat the same pattern. This time we're going kind of the opposite way. So it goes down and back up. Comes back to the original position. Down, back up. Comes back to its original position. Okay, so there's a lot of different questions you can ask now. Like for example, if I wanted to determine the amount of minimums from 0 to 4 pi over 3, that would be 2, because it hits a minimum value twice. Same thing with the number of maximums. There's 2 maximums from 0 to 4 pi over 3 because it hits the peak twice. Okay, now let's do the opposite. So instead of going from the function to the graph, we're going to go from the graph to the function. So this right here is our final answer. And then just recognize that it actually will keep going here. It will continue to the left and the right to negative infinity and infinity. All right, now let's actually write what the sine function or cosine function is for this one. So this will probably be the hardest question in the video. What I want to do is we're going to write 2 separate trig functions for this graph. One will be represented as sine, and then we're going to write an equivalent as cosine. Okay? And the reason why this is a particularly challenging question is because there's a horizontal shift here, and that's going to make things a little bit more difficult. But the same kind of process is going to start this question. We're going to start by recognizing the midline, our k value, and that's going to be equal to 1. That's what the line that splits the function in half. The amplitude, which is the distance from the midline to the maximum or the minimum, is 1. And in this case, the a value is equal to 1. The period is it is essentially the time or the distance of one cycle. Okay, this one is a little bit more challenging to see, but if I start here, notice if I were to kind of shift this to the right, shift this function to the right, the period is 4 pi. So what I can do is imagine we shifted this to the right. That would give us a period of 4 pi here. Okay, and so the period in this case is 4 pi. So the period P is equal to 4 pi. Another way you can find the period, if you were stuck, is measure the distance from one peak to the next peak. So this right here is pi over 2. Well, this is going to be 4 pi over 2 plus pi over 2. And so that is 9 pi over 2. the distance between these 2 points is going to be the difference of them. 9 pi over 2 over pi over 2 is 8 pi over 2, and so you get 4 pi. That's a little bit trickier in this case, but one way to find the period is to measure the distance from one peak to the next peak with these simple trig functions. So the period is going to tell us how to find the b value, because remember, the period is equal to 2 pi over b, and b is going to be our b value here. So let's solve for b. B is going to be equal to, well, what we can do is multiply by b on both sides, like that, and let's divide by 4 pi. So b is equal to 2 pi over 4 pi, which is equal to 1/2. So the b value in this case is 1/2. Okay, this is where it's going to get a little tricky, is there's a horizontal shift here. So imagine I were to start here. Notice that if I were to start here at 0, 1, that would be a positive sine function because we're starting in the middle. This sine function is shifted to the left pi over 2 units. Okay? So it's shifted to the left pi over 2 units. And so this distance here is pi over 2. So it's shifted to the left pi over 2. So there's a horizontal shift here. Horizontal shift. We're going to say it's pi over 2 units left. Okay? Because it's shifted pi over 2 units left, the h value is equal to negative pi over 2. Okay? So the h value is going to be our horizontal shift. If it's shifting to the left, the h value is going to be negative. If it's shifting to the right, the h value is positive. Okay? This is where it gets tricky. It's because the general function that we talked about is this. Here's the general form. Plus k, which is the value on the outside. This is the general form. The reason why it's tricky is because, remember, the signs are always going to be different when we have our final answer, and the reason why that is because there's a negative here. Okay, so what I mean by that is let's take these and let's plug in each of these values into their respective spots into this general formula. So the a value is 1. We'll leave that alone. So it's sine. Well, b is 1/2 x minus negative pi over 2. Okay, so minus, we're plugging in negative pi over 2 here, and so we're subtracting minus pi over 2, which means there's a plus here. Okay, so this is plus pi over 2, which is an indication that we're going to the left. Okay, so there's a 1 here on the outside too. And then lastly, we just have a plus 1 on the outside. So this right here is one trig function that models this equation, or this function graphed up here at the top. That's one of them. Okay? Let's write another one in terms of sine. Okay? It's going to be the same exact thing, except let's start here at the top. So I'll write or. We're going to start here at the top, and then instead of starting in the middle and shifting left, like we did right here, let's start at the top, and we're going to shift to the right. So remember, if it starts at the top, it's a positive cosine function, and then we're shifting to the right pi over 2. which means we're going to be subtracting pi over 2 inside the trig function. Okay. So the answer here, our second function, is going to be the same exact thing, except as a cosine function, it's going to be 1/2 x minus pi over 2. Because we're shifting, if we want to treat it as a cosine function, we have to shift it to the right instead of to the left. Okay, if we want to treat it as a sine function, we're going to shift it to the left. So these two functions here they're the same exact thing. They are just written differently. They both model this graph at the top.